Welcome to our deep dive all about rockets.
Yeah, rockets.
You've given us some really amazing Chinese sources on this topic.
A really interesting mix, yeah.
You've got historical accounts, like deep technical explanations,
Ah.
and even some like thought-provoking perspectives on the impact of rockets
Yeah.
on society.
It is, it's a really beautiful mix of art and science
It's going to be fascinating.
and philosophy,
Yeah.
which always makes things more interesting.
Okay, so our mission today is threefold.
Okay.
First, we want to make sure you really understand how rockets work.
Mm-hmm.
From the basic physics all the way up to some of the like cutting-edge design innovations.
Okay.
Second, we'll trace the evolution of rocket technology,
Right.
highlighting those pivotal aha moments that kind of propelled the field forward.
Right.
And finally, we'll touch on the social and cultural impacts of rockets,
Okay.
from their ancient roots in fireworks
Uh-huh.
to their potential to shape the future of humanity.
That's pretty ambitious.
It is.
Yeah.
It is.
But I think we can, I think these sources have enough to cover all that.
Let's get started then.
Right.
One thing that immediately caught my eye in these sources was the link that they make between ancient Chinese fireworks
Okay.
and the origins of rockets.
Yeah.
They even mentioned a specific firework
Uh-huh.
called the fire dragon emerging from water from the Songxi dynasty.
Interesting.
Apparently this thing used gunpowder for propulsion.
Which is incredible when you think about it.
Yeah.
Those early engineers
Right.
really understood the basic principles of rocketry,
Yeah.
even though they didn't have the sophisticated tools or materials.
I was going to say, maybe we need to do a little bit of science here.
Right.
How did those early rockets actually get off the ground?
Sure. So gunpowder is a mixture of chemicals
Okay.
that, when ignited, burns extremely rapidly,
Yeah.
produces a large volume of hot gas. That gas expands rapidly and needs to escape,
Uh-huh.
creating a force in one direction. All right. Now, Newton's third law states that for every action,
Yeah.
there's an equal and opposite reaction.
Uh-huh.
In the case of a rocket, the action is the hot gas
Right.
being expelled out of the rocket engine.
Yeah.
And the reaction is the rocket being pushed in the opposite direction.
So that's what creates thrust.
That's how thrust is created.
Okay.
That's what propels the rocket upwards.
So that simple principle of action and reaction
Right.
is at the heart of it all.
Uh-huh.
Yeah.
From those early fireworks to the massive rockets
It is fascinating.
launching today.
Yeah.
But,
But as you can imagine,
yeah,
gunpowder for propulsion came with its own set of challenges.
it did.
The sources definitely mention some limitations
Yeah.
with those early gunpowder rockets.
For sure.
So what were some of the biggest hurdles?
Well, one of the biggest issues was control,
Okay.
or rather the lack of it.
Okay.
With gunpowder,
Uh-huh.
once you light it, there's no way to really regulate the burn rate or the direction of the thrust.
Oh, interesting.
It's basically all or nothing.
Right.
This made early rockets
Yeah.
pretty unpredictable
Uh-huh.
and limited their potential applications.
Okay.
Another challenge
Yep.
was the duration of the thrust.
Okay.
Gunpowder burns very quickly,
Right.
which means the thrust it produces
Yeah.
only lasts for a short period of time.
So those early rockets were basically like giant firecrackers.
A giant firecracker.
A lot of power in a short burst,
Yeah.
but not much finesse,
Right.
not much control.
Exactly.
That's probably why the development of liquid fuel was so important, right?
Absolutely.
Yeah.
Liquid fuel was a game changer
Okay.
in so many ways.
Yeah.
It offered a level of control and efficiency
Uh-huh.
that was simply impossible with gunpowder.
Okay.
To understand why it was such a significant leap forward,
Yeah.
we need to talk about a concept called specific impulse.
Okay.
Specific impulse.
Let's break this down.
Right.
What exactly is specific impulse?
Specific impulse is essentially a measure of fuel efficiency.
Okay.
It tells us how much thrust we can get from a given amount of fuel.
All right.
The higher the specific impulse,
Mm-hmm.
the more efficient the fuel.
Okay.
And that means we can achieve greater speeds
Right.
and travel farther distances
Yeah.
using the same amount of fuel.
So like getting better mileage out of your car,
You got it?
you can go further on a single tank of gas,
Right.
which is crucial for space exploration because every ounce of fuel
Yes.
adds weight, which makes it harder to get off the ground.
Makes it harder and harder.
I'm guessing liquid fuels have a much higher specific impulse
They do.
than gunpowder.
You got it.
Okay.
Liquid fuels like the liquid hydrogen
Uh-huh.
and oxygen combination
Oh, yeah.
used in the space shuttle
Right.
have a much higher specific impulse
Yeah.
than gunpowder.
Okay.
This means they can generate much more thrust for a given amount of fuel.
Makes sense.
Which is essential for achieving orbit and beyond.
The sources mention that liquid fuel also gave rockets the ability to be reignited in flight, which was completely mind-blowing to me.
It's pretty amazing.
How is that even possible?
It all comes down to that controllability that we talked about. With liquid fuel, we can precisely regulate the flow of fuel in oxidizer into the combustion chamber, which allows us to adjust the thrust, stop the engine entirely, and then restart it again when needed. This is crucial for multi-stage rockets.
Multi-stage rockets, which is another concept that the sources highlight.
They do.
Multi-stage rockets, basically you're stacking multiple rockets on top of each other, right?
Imagine a rocket with 2 stages, each with its own engine, and liquid fuel supply. The first stage ignites, blasting the rocket off the ground, carrying it up to a certain altitude when its fuel is depleted. The first stage detaches and falls back to Earth. Then the second stage ignites using its own fuel to push the rocket even higher, reaching orbital velocity or beyond.
So you couldn't do that with gunpowder.
This wouldn't be possible with gunpowder because once it's ignited, you can't stop and restart the burn. Liquid fuel provides that.
That crucial controllability.
Crucial controllability.
Okay, so liquid fuel is a game changer.
It is.
Not just for efficiency, but for its flexibility, controllability, enabling those complex maneuvers and multi-stage rocket designs.
It really revolutionized the entire field of rocketry.
It's amazing how a simple change in fuel can completely revolutionize a technology. But let's move beyond the fuel itself. The sources also delve into the design process. It's like taking a peek behind the curtain at all the meticulous engineering that goes into building a rocket.
It is. Designing a rocket is no walk in the park.
What are some of the biggest hurdles?
Well, imagine you're building a skyscraper that has to withstand incredible forces and temperatures, all while being as light as possible.
Oh, wow.
That's rocket design in a nutshell. One of the biggest challenges is structural design. You've got the immense thrust of the engines pushing the rocket upward, gravity pulling it down, and aerodynamic forces trying to tear it apart.
Oh, that sounds intense.
It's all about finding that perfect balance between strength and weight.
Strength and weight.
You need materials that are incredibly strong, but also lightweight enough to allow the rocket to get off the ground. That's where material science comes in. And the sources highlight the incredible advancements that have been made in this area.
So I'm guessing we're not using wood and canvas anymore.
Not quite. Modern rockets use some pretty high-tech materials.
Like what?
Like carbon fiber composites.
Carbon fiber composites?
Or CFRP. These composites are made by weaving together strands of carbon fiber and embedding them in a resin. The result is a material that's incredibly strong and stiff, but also surprisingly light.
Wow.
The sources mentioned that SpaceX, for example, uses CFRP extensively in their Falcon 9 rockets.
So they're really strong.
Incredibly strong.
But also really light.
And lightweight,
Which is what you need.
It's the perfect combination.
To get off the ground.
Exactly.
Now, what about the extreme temperatures?
Ah, yes. Thermal management.
Thermal management.
Another major hurdle. It's a bit like trying to keep a delicate flower alive in both a furnace and a freezer at the same time.
Oh, wow.
You have rocket engines burning at thousands of degrees, generating intense heat, while other parts of the rocket are exposed to the extreme cold of space.
So how do you protect?
It requires a multi-pronged approach. First, we use specialized insulation materials to shield sensitive components from the intense heat of the engines.
That makes sense.
Think of it like wrapping those delicate parts in a high-tech thermal blanket.
Like a thermal blanket.
Exactly.
Gotcha.
Then for components that need to stay warm in the cold of space, we use heaters. And carefully designed thermal pathways to maintain a stable temperature. And finally, some components, especially electronics, generate their own heat. So we need to incorporate cooling systems.
Oh, wow.
to prevent them from overheating.
So it's like you're designing a climate control system.
It is like designing a giant, high-stakes
for the whole rocket.
Climate control system for the entire rocket.
Wow.
And we're not done yet.
What else is there?
There's another challenge that often gets overlooked.
Okay.
But it's equally crucial.
All right.
Vibration control.
Vibration control.
Those powerful rocket engines don't just create thrust.
Right.
They also generate intense vibrations that can shake the entire structure apart.
So the whole rocket's shaking.
That's a pretty good analogy.
Wow.
And if those vibrations aren't managed properly, they can wreak havoc on the delicate instruments and electronics on board.
Okay.
Imagine trying to operate a sensitive scientific instrument while riding a jackhammer.
Right. It wouldn't work very well.
It wouldn't work very well.
So how do you stop a rocket from rattling itself to pieces?
Again, it's a combination of clever design and specialized components. The sources talk about dampeners and absorbers.
Dampeners and absorbers.
Which are designed to absorb and dissipate those vibrations.
Okay.
Think of them like the shock absorbers in your car. But for a much more extreme environment, they help isolate sensitive equipment from the intense vibrations of the engines and the aerodynamic forces acting on the rocket.
So it's like a giant suspension system
It is.
for the entire rocket.
Like a giant high-tech suspension system.
Wow, that's fascinating.
For the entire rocket.
So we've talked about structural design, thermal management, and vibration control.
Yeah.
It's amazing how they overcome these hurdles
It is.
to create these incredible machines.
And when you consider those super heavy lift rockets designed for ambitious missions, like building large space stations or lunar bases, the challenges become even more daunting.
The sources really emphasized how essential those are.
Absolutely.
For future space exploration.
Well, they're crucial.
What makes them so crucial?
Well, think about what it takes to build a lunar base or a large space station. We're talking about transporting huge amounts of material, habitat modules, life support systems, construction equipment, scientific instruments, food, water, and everything else needed to sustain human life and conduct research in space.
It's a lot of stuff.
But we're not talking about a few suitcases here. We're talking about millions of pounds of cargo.
Millions
of pounds.
That's incredible.
To get all that into space,
you
need some serious lifting power.
I remember the sources mentioned the SpaceX Falcon Heavy.
Yes, the Falcon Heavy.
Which is currently the most powerful rocket.
It's the most powerful operational rocket in the world.
Wow, okay.
It can lift over 140,000 pounds into low Earth orbit.
140,000 pounds.
That's roughly the equivalent of a fully loaded Boeing 737 airplane.
A fully loaded 737.
A 737.
Wow, imagine that.
That puts things into perspective.
It does.
That is a lot of weight.
It's a colossal amount of weight. And it makes you realize how far we've come.
It really does.
From those early gunpowder tubes to these colossal machines.
These massive machines.
Capable of carrying humanity's dreams.
Absolutely.
Beyond Earth.
It's a testament to human ingenuity.
It is. It is.
And our relentless pursuit of exploration.
But as we reach for the stars, it's important to be mindful of our impact down here.
Absolutely.
The sources also delve into the environmental concerns surrounding rocket launches.
It's not just about getting to space. It's about doing it in a way that's sustainable and doesn't harm our planet.
What are some of the environmental challenges?
Traditional rocket fuels, like kerosene, are a major source of pollution. They release greenhouse gases and other harmful pollutants into the atmosphere, contributing to climate change and air pollution.
And the sonic booms created during launch can be pretty disruptive.
Can disrupt local wildlife and communities.
So it's not just the exhaust fumes.
It's not just the exhaust.
It's the noise pollution as well.
It's the noise as well.
What are some of the solutions being explored?
That's where the research into green rocket fuels comes in.
For rocket fuels.
The sources highlight some exciting possibilities.
Like what?
Like liquid hydrogen.
Liquid hydrogen.
Methane.
Methane.
And even bio-derived fuels.
Wow. Okay.
Liquid hydrogen, for example, produces only water vapor as exhaust.
Only water vapor.
Which is a huge improvement.
That's amazing.
Over traditional fuels.
Are there any drawbacks?
Well, liquid hydrogen is very difficult to store and handle.
Okay.
Because it needs to be kept at extremely low temperatures. But the potential environmental benefits are significant.
Okay.
And it's definitely a promising avenue for future research.
What about methane?
Methane is another promising option.
Okay.
Because it burns more cleanly than kerosene. Okay. And can be produced from renewable sources.
Right.
Reducing our reliance on fossil fuels.
Okay.
Plus, it's less expensive than traditional rocket fuels.
So it's cheaper and better for the environment.
It is.
Wow.
And the reusable nature of the Falcon 9.
Right, because they're using that.
SpaceX is already using methane liquid oxygen fuel in their Falcon 9 rockets.
Oh, okay.
So they're really leading the charge
in
developing sustainable rocket technology.
It's encouraging to see that environmental considerations are becoming a more prominent part of the conversation.
They're becoming increasingly important.
Around space exploration.
Absolutely.
It's not just about getting there.
It's not just about getting there.
It's about how we get there.
It's about how we get there.
And the impact.
And the impact we have.
Yeah, we have.
Along the way.
Yeah, it's amazing how these machines captured our imaginations.
They have
centuries.
Centuries.
I mean, who hasn't looked up at the night sky and wondered what it would be like to blast off into space?
It's a universal dream.
It is.
From ancient myths and legends to modern science fiction.
Yeah.
Rockets represent our ambition, our thirst for exploration, and our desire to push beyond the boundaries of what we know.
They symbolize the human spirit
They do.
of ingenuity and our relentless quest to explore the unknown.
Absolutely.
The sources specifically mention science fiction.
Yeah.
And I think that's a really interesting angle.
It is.
It's amazing how authors and filmmakers have used rockets as symbols of human ingenuity.
They have.
And our drive to explore the cosmos.
Think about iconic images like the sleek spacecraft in 2001.
Right.
A Space Odyssey.
Yes.
Or the Millennium Falcon blasting off into hyperspace.
Yeah.
These images have become ingrained in our culture, shaping our perceptions of space travel and inspiring generations of scientists and engineers.
And it's not just about fantasy.
It's not just fantasy.
And escapism.
Right.
Science fiction often explores the ethical and philosophical questions surrounding space exploration.
Absolutely.
Using rockets as a springboard.
It asks us to consider the implications of our actions.
Right.
What does it mean to leave Earth
and
venture into the unknown?
What responsibilities do we have?
What responsibilities do we have?
To the planets.
To other planets.
And potential life forms.
And potential life forms.
We might encounter.
That we might encounter.
What kind of future do we want to create?
What kind of future do we want to create in space?
In space.
These are questions that become even more relevant as our technology advances and our reach extends further into the cosmos.
So it's like science fiction is a way for us to rehearse.
It's a way to grapple with the potential challenges and consequences
of space exploration.
Before
we actually face them.
Before we actually have to face them.
Right.
But let's bring things back down to Earth.
Okay.
Literally.
Yeah.
The sources also point out that rocket technology has had a profound impact on our lives here on the ground.
Absolutely.
In ways we might not even realize.
Yeah, it's not just about launching satellites.
Right.
Or sending astronauts into space.
Exactly.
What are some of the ways rocket science has shaped our world?
Well, one area is material science.
Material science.
The extreme conditions that rockets have to endure have driven the development of incredibly strong and lightweight materials.
Like those carbon fiber composites we talked about?
Like those carbon fiber composites?
Yeah.
Those are now used in everything.
Yeah.
From airplanes and cars to bicycles and sporting goods.
It's amazing how technology developed for space
It is.
ends up in these everyday things.
It finds its way into so many different aspects of our lives.
And that's just one example.
That's just one example. Rocket technology has also advanced our understanding of propulsion systems, combustion and fluid dynamics, which has led to improvements in things like jet engines.
Jet engines.
Gas turbines used for power generation.
Wow.
And even medical devices.
It's incredible how something as seemingly specialized as rocket science.
It really speaks to the power of scientific inquiry and the interconnectedness of knowledge. But of course, we can't talk about rockets without acknowledging their role in military history and international relations. The sources touch on this aspect as well.
Yeah.
And it's a topic that deserve careful consideration.
It's definitely a complex and sensitive issue.
It is.
But it's important to recognize that rockets have played a significant role
Absolutely.
in shaping global politics.
They have.
And the balance of power.
The development of ballistic missiles during the Cold War was a major turning point.
Yeah.
These weapons, essentially long-range rockets, capable of carrying nuclear warheads, dramatically escalated the stakes of global conflict and led to an arms race between the United States and the Soviet Union.
It's a sobering reminder that technology
can
be used for both good and evil.
It highlights the duality of technology and the importance of ethical considerations in its development and use.
The sources also touch on the role of rockets in national prestige and the competition between nations.
It's almost like a modern-day space race.
It is. It is.
Where countries vie for bragging rights and technological superiority.
What are some of the driving forces?
Well, there's definitely an element of national pride.
National pride.
Being the first to achieve a significant milestone in space exploration. Like launching a satellite, sending a human into orbit, or landing on the moon, is seen as a symbol of a nation's technological prowess and global standing.
And it's not just bragging rights.
It's not just bragging rights.
There's also significant political and economic implications.
Absolutely.
Advancements in space technology.
Often translate into advancements in other fields. Leading to new industries, jobs, and economic growth.
And in the context of global politics.
Demonstrating leadership in space exploration can be a way for nations to exert influence. Forge alliances. And shape the future of space exploration.
It's a very complex thing.
It's a complex interplay of science, technology, politics, and economics.
Yeah, it is.
But as we delve deeper into the world of rockets, the sources also offer us a glimpse into the future of rocket design.
Future tech time.
And let me tell you, it's looking pretty exciting.
I'm always eager to hear about the next big thing.
Well, one area that's generating a lot of buzz is advanced propulsion systems.
Advanced propulsion systems.
We've talked about liquid fuel and solid fuel rockets. But there are researchers exploring entirely new ways to propel spacecraft. Ways that could potentially revolutionize space travel.
Give us the sci-fi rundown.
One concept that's been around for a while, but is gaining renewed interest, is nuclear propulsion.
Nuclear propulsion?
It involves using a nuclear reactor.
A nuclear reactor.
To heat a propellant, like hydrogen, to extremely high temperatures.
Wow.
Which would then be expelled through a nozzle to create thrust.
So we're talking nuclear-powered rockets.
We are.
That sounds both incredibly powerful.
It's an incredibly powerful concept.
And incredibly dangerous.
You're right. It's a double-edged sword.
Yeah.
Nuclear propulsion has the potential to significantly reduce travel times. For deep space missions.
Deep space missions.
We're talking about trips to Mars.
To Mars.
In a matter of months.
Months. Wow.
Rather than years. Which would open up a whole new realm of possibilities.
That would be a game changer.
It would be revolutionary.
Yeah.
But what about the risks?
Launching a nuclear reactor into space?
There are definitely safety concerns.
Yeah.
And that's why research in this area has been cautious. The main challenge is ensuring the safe containment of the nuclear material. Both during launch and throughout the mission. But researchers are working on innovative designs that could mitigate these risks.
So it's a technology with enormous potential.
It is.
But it requires a lot of thought.
It requires careful consideration and rigorous safety protocols.
What other advanced propulsion systems are on the horizon?
Another area that's getting a lot of attention is electric propulsion.
Electric propulsion.
This involves using electricity to accelerate charged particles, creating thrust.
So instead of burning fuel,
we're
using electricity
to propel spacecraft.
How
does that work?
There are a few different types of electric propulsion systems, but the basic principle is the same. You use an electric field to accelerate ions, which are charged atoms, and then expel them from the spacecraft, creating thrust.
So it's like a super efficient ion engine.
It's actually not that far off.
Really?
Ion engines are a type of electric propulsion that's already being used on some spacecraft.
They are? Okay.
They're incredibly efficient, meaning they can produce a lot of thrust over a long period using a relatively small amount of propellant.
But they're not very powerful.
Okay. So they're not suitable for launching rockets from Earth.
So they're more like long-distance cruisers.
Slowly but steadily accelerating over time. Okay.
The sources also mention something called a plasma thruster.
A plasma thruster? Is that another type of electric propulsion?
It is.
Okay.
Plasma thrusters use electricity to heat a gas, usually xenon, to a plasma state. Plasma is essentially a superheated gas where the atoms have been stripped of their electrons.
Oh, wow.
Creating a mix of charged particles.
Interesting.
This plasma is then accelerated through a magnetic field, creating thrust.
So you're creating plasma.
We're creating plasma.
And then using that to propel the spacecraft. That's incredible.
It's a fascinating technology.
Are plasma thrusters more powerful than ion engines?
They are more powerful than ion engines.
Okay.
But they still require a lot of electricity to operate.
So we're probably not going to see them.
Not for launching from Earth.
Anytime soon.
Not anytime soon.
But for deep space missions. They seem like a promising option.
They offer a balance of efficiency and thrust that could be ideal for long-duration missions.
So we've got nuclear rockets that could get us to Mars in a flash.
In a matter of months.
Yeah.
Electric propulsion systems that could slowly but steadily propel us.
Across the solar system. What other far-out ideas are rocket scientists dreaming up?
Well, one concept that's been around for a while, but still captures the imagination, is solar sailing.
Solar sailing.
It involves using a large, reflective sail.
A sail?
To capture the momentum of sunlight.
Oh, wow.
Propelling the spacecraft forward.
So like a sailboat.
But
powered by sunlight instead of wind. That's amazing.
A beautiful concept.
How do you steer a solar sail?
That's one of the challenges.
Yeah.
Steering a solar sail involves changing its orientation relative to the sun, which can be done by adjusting the sail's reflectivity.
Right.
Or using small vanes.
Okay.
Or control surfaces.
So you're adjusting the sail.
To
control where it goes.
It's
like tacking a sailboat.
But
on a cosmic scale. Wow.
It requires precise calculations and careful maneuvering.
But the idea of harnessing the power of the sun...
This is a remarkable concept.
...to propel spacecraft is incredible.
And the beauty of solar sailing is that you don't need to carry any fuel.
Right.
You're essentially harnessing a free and inexhaustible energy source.
The sun.
Talk
about sustainability.
It's the ultimate form of sustainable propulsion.
So we've got nuclear propulsion. Electric propulsion.
Right.
Solar sailing. The future of rocket design is going to be wild.
It's going to be an exciting time for space exploration. And these advancements in propulsion technology are just one piece of the puzzle.
Oh, okay.
The sources also touch on some of the other emerging trends in rocket design.
Like what?
Well, one trend that's already starting to reshape the industry is 3D printing.
3D printing.
Companies like Relativity Space are using giant 3D printers to manufacture entire rockets.
3D printed rockets.
How
does that even work?
That's pretty amazing, actually.
Yeah.
These 3D printers use metal alloys as their ink.
Wow.
And build up the rocket layer by layer.
Okay.
Creating complex structures and geometries that would be impossible to achieve with traditional manufacturing methods.
That sounds like something straight out of science fiction.
It's a game changer.
Yeah.
For the aerospace industry.
It's incredible how technology is transforming the way we design and build rockets.
It's a revolution.
Yeah.
In manufacturing.
What other exciting innovations are on the horizon?
Another trend that's gaining momentum is the development of reusable components. We've already seen this with SpaceX's Falcon 9, which can land its first stage back on Earth after launching a payload into space. This reusability dramatically reduces the cost
That's good.
of the spaceflight, making it more accessible. and sustainable.
It's like the difference between buying a new car every time you want to go somewhere versus just refueling your existing car.
It's a game changer for the economics of space exploration.
It is.
And reusability is not just limited to the first stage of a rocket.
Okay.
Companies are working on designs for fully reusable spacecraft.
Wow.
Which could further reduce costs.
Right.
And open up new possibilities for space travel and exploration.
So it sounds like the future of rocket design.
It's all about pushing boundaries, embracing innovation, and finding creative solutions to the challenges of space travel.
But as we venture further into space, it's important to remember that it's not just about the technology.
You're absolutely right. It's about the people.
Yeah.
Behind all those incredible machines and groundbreaking innovations are the brilliant minds, the dreamers, the risk-takers, who dared to imagine a future beyond Earth.
Yeah.
These sources really highlight the human element of rocket design and space exploration.
It's easy to get caught up in the technical details.
It is.
And forget that it's human curiosity and ingenuity that drive us to this point.
Exactly.
Yeah.
We read about those early pioneers who faced skepticism and ridicule, who tinkered in their workshops and launched rockets in their backyards, driven by a passion to explore the unknown.
It's inspiring.
Their stories remind us that progress is often driven by individuals who dare to challenge conventional wisdom and pursue their dreams, even when others doubt them.
Even when others doubt them.
It's a powerful reminder that even in a field as complex as rocket science, it's ultimately the human spirit that drives innovation and exploration.
Yeah.
And these sources don't shy away
from
exploring the philosophical implications of space exploration either.
It got pretty deep.
They delve into some pretty deep questions about our place in the cosmos and what it means to be human.
Yeah. When we contemplate the vastness of the universe, it can be humbling.
It's both humbling and awe-inspiring.
What are some of the philosophical questions?
Well, they touch on some big ones.
Okay.
Like, are we alone in the universe?
Right.
What is our purpose here on Earth?
Okay.
What are our ethical obligations to other planets?
Yeah.
And potential life forms?
Okay.
What kind of legacy will we leave for future generations?
Yeah.
Both here on Earth and potentially beyond. These are questions that philosophers have been grappling with for centuries.
Right.
But they take on a new urgency.
Yeah.
As we gain the capability to actually travel to other worlds.
Yeah, it's like space exploration is a catalyst for philosophical inquiry.
It forces us to re-examine our assumptions.
Right.
About ourselves and our place in the grand scheme of things.
This has been such an incredible deep dive into the world of rockets.
It really has.
We've covered so much ground.
We've gone from the basic physics of how rockets work to the cutting-edge technologies that are shaping the future of space exploration.
Right.
And we've even touched on some of the philosophical questions.
It's been quite a journey.
That arise when we contemplate the vastness of the cosmos.
Yeah, it has.
And it's clear that the story of rocket design is far from over.
Yeah, it feels like we're just getting started.
With the emergence of private space companies, the growing interest in space tourism, and the renewed focus on exploring Mars and beyond.
We're on the cusp of a new era.
A new era of space exploration.
Space exploration.
It's an exciting time to be alive.
It is.
And I'm eager to see what the future holds.
Who knows, maybe one day we'll be having this podcast from a lunar base.
From a lunar base.
Or even a Martian colony.
That would be amazing.
But until then,
keep
looking up at the stars.
Keep looking up.
Keep asking those big questions.
Asking the big questions.
And keep exploring.
Keep exploring.
The universe is full of wonder and possibility.
It is.
And it's waiting for us to uncover its secrets.
And that's a wrap on our deep dive into rockets.
Thanks for joining us.
Keep exploring.